right, strap in, everyone. Today we're going deep into cybersecurity. More specifically, a vulnerability that researchers have found.
Yeah, it's pretty wild, actually.
Yeah, so we've got a presentation slide deck and a research poster to pick apart today.
That's right.
Both detail a new type of attack that can trick AI devices. And it's not just theory, they actually pulled it off.
Yeah.
Kind of scary how easy it was, too.
It is.
So we're seeing more and more edge computing these days, putting serious AI into little devices. But, you know, like anything connected, they become targets. Someone could steal data or make them do things they shouldn't.
Exactly. That's what we're talking about today, actually. This attack is called Electromagnetic Fault Injection, or EMFI.
EMFI.
Okay. Sounds intense, so what's that all about?
Well, think of it like this. You're working on a puzzle. You're really focused, right? And then someone keeps flickering the lights.
Ugh, annoying.
Yeah, it messes you up. EMFI is kind of like that. Precisely timed electromagnetic pulses to disrupt the device. So they're zapping it with electromagnetic energy.
You got it.
And that makes it what? Make mistakes or something?
Yeah, exactly.
Wild.
And get this, they used stuff anyone can buy, like a Raspberry Pi, a chip whisperer, and a chip shouter.
Hold on. So anyone could order these things online and mess with AI, like self-driving cars?
Potentially.
Or like medical devices?
It's possible. That's what makes this scary. This isn't some theoretical thing. It's happening now.
Okay, yeah. I'm a little freaked out now.
Yeah.
But how does this zapping make the device mess up?
Right. Well, it's not like frying the circuits or anything. They found they could get 3 main results. System crashes, the device just shuts down.
Okay.
Failed inferences, meaning it can't make a decision.
Makes sense.
And the big one, misclassification.
Misclassification. So like it makes the wrong decisions. Like what would that look like in real life?
Say an AI is looking at a picture, right, to tell if it's a cat or a dog. With EMFI, you could basically make it only see black and white.
Ah, so it can't pick up on the details it needs?
Right. It's forced to make a bad call.
So they're tricking it, essentially.
Yeah.
But how do they even know what kind of zap will cause that specific thing to happen?
Well, that's where it gets even more interesting. What they were working with, it's called a black box scenario.
Black box? Oh, are we doing spy stuff now?
No. It just means they didn't have the details of how the NCS2 works internally. They were basically poking around to see what they could manipulate.
Wow, so they're hacking this thing blindfolded, essentially.
Pretty much.
And they still messed it up.
Yep. They found 2 main ways to cause these misclassifications. The first, they called Fault 1, forces the device to output only integers. Kind of like making it round up or down all the time.
So it's always guessing cat because it can't see the subtle differences anymore.
Exactly. It creates a bias towards a specific answer.
Yeah.
And then there's Fault 2. It's a bit more complicated. This one messes with what's called the activation function in the neural network.
Okay, losing me a bit there.
It causes a whole bunch of errors, a cascade leading to misclassification.
It's like a domino effect.
Yeah, like a domino effect. Knock one over and it messes up the whole thing.
Gotcha. So they're finding these tiny pressure points in the AI and exploiting them.
That's a good way to put it.
That's pretty intense.
It is. And what makes it even more concerning is that the timing of this zap had to be really precise. Like they had to hit the device at just the right moment.
Oh, so like trying to hit a moving target. But I thought AI was supposed to think in a, like, predictable way.
You'd think so, right. But the thing is, the timing of what's called the inference process, that's when the AI actually makes the decision. Well, it can vary. It's not always a fixed, predictable thing.
Wait, so you're saying it has to be timed perfectly? But the AI's thinking isn't predictable, so how do they even do it?
Yeah, that was a big challenge for them. What they had to do was use what they called a burst mode. So basically sending out a bunch of pulses really fast, increasing the chances of hitting that right moment.
So, like, spraying and praying with electromagnetic pulses, hoping one hits the target seems a little, I don't know, brute force.
Yeah, kind of. But even with that, they still got misclassification rates between 8% and 20%.
20% doesn't sound that bad. Honestly, most systems have some room for error, right?
Yeah.
Like, my phone autocorrects wrong words all the time, and it's not the end of the world.
True, for everyday stuff. But think about critical systems. Self-driving cars, medical diagnoses, finances. Even a small error rate there could be really bad.
Okay, yeah, back to being freaked out. So, what can we even do about this? Is there a way to protect these devices from EMFI attacks?
That's the big question. This research is definitely a wake-up call. We need to start thinking seriously about building better defenses into these AI systems.
Okay, like what? Electromagnetic shields. Should I be wrapping my smart devices in tinfoil?
Haha, maybe not tinfoil, but there are some things we can look into. For example, tamper-proof hardware would make it physically harder to get to the important parts of the device.
Makes sense. Make it tougher to actually mess with the circuitry. What else?
On the software side, we need ways to detect these attacks and respond to them. Like imagine a system that can tell it's being hit with those pulses and then, I don't know, do something to protect itself.
Sounds futuristic. Is that something we could do soon, or is this years away?
Hard to say. But the good news is this research is bringing attention to the issue. So hopefully more resources and people will focus on solutions.
So are you saying we should just give up on AI and go back to living in caves?
No, not at all. AI can revolutionize things, but we have to be smart about it. Can't just assume security will happen on its own.
So what's the main thing you want people to take away from this? What should they do with this information?
Awareness is key. People need to know about the risks of edge computing and AI, and they should demand better security from the companies making these devices.
Don't be afraid to ask questions, right?
Exactly. Ask how your devices are protected. Ask about the vulnerabilities. The more we talk about this stuff, the more pressure there is on manufacturers to prioritize security.
You know, it's kind of ironic we're talking about AI, this advanced technology that's supposed to make things easier and safer. But it could also make us more vulnerable.
That's the thing with any new technology, right? Two sides to the coin. It's up to us to make sure it's used for good.
We've only just scratched the surface here, haven't we? So much more to this topic.
Definitely just the beginning of the conversation. We should all keep digging into this, exploring the research and staying engaged with these issues.
And maybe invest in some good tinfoil, just in case.
All right. Maybe not tinfoil. But stay informed and keep asking the tough questions.
Well, everyone, we've explored this wild world of EMFI attacks and the vulnerabilities in edge AI devices. It's a reminder that as AI becomes more a part of our lives, so do the risks.
Absolutely. We've seen how even simple tools can be used to manipulate these devices, potentially leading to some serious consequences. But awareness and being proactive can make a difference.
So next time you see that little device on your desk, remember the power it has for good and for bad.
And remember that the future of AI isn't set in stone. We can all shape it responsibly.
Thanks for joining us on this electrifying deep dive. Stay curious, stay informed, and stay safe out there. You know, it's wild to think they did all that without even knowing how the NCS2 works.
It is. That black box thing is kind of what makes it so fascinating and scary. Like they found these vulnerabilities just by, poking around.
Yeah, like finding a secret door you didn't even know was there.
Yeah.
Imagine if they had a blueprint of the whole system.
Right. That's what keeps cybersecurity people up at night. I mean, these AI systems are only getting more complex, so the potential for attacks just keeps growing.
Like an arms race almost. The better the defenses, the more sophisticated the attacks get.
Yeah, exactly. Cat and mouse game. And the stakes just keep getting higher, especially when you think about AI and, critical infrastructure.
So I guess the takeaway is no system is perfect.
Right. We have to move away from trying to prevent every attack. Instead, we need to build systems that can adapt and recover.
So more like an immune system, not a fortress.
Yeah, good analogy. AI that can tell it's under attack. Isolate the problem. Keep working even when things go wrong.
Sounds like we need a whole new approach to security then. Something that can keep up with these evolving threats.
Absolutely. We need to go beyond the old ways of doing cybersecurity. It has to be part of how we design AI from the start.
Well, we've reached the end of our deep dive today. We've explored these EMFI attacks, the vulnerabilities in edge AI, and the challenges of keeping these systems secure.
Yeah. But remember, this is just the beginning. AI is only going to advance. We can expect to see even crazier attacks in the future.
So what's the one thing you hope people listening remember?
Stay vigilant, be informed, ask questions, and don't be afraid to, demand better security from the people making this tech.
The future of AI is in our hands. We need to make sure it's a future we can all trust.
Well said. Thanks for joining us as we explored AI security. Remember, knowledge is power. Use it wisely.
And until next time, keep that curiosity going.